Okay, my people, let's look at 6-5, part 2, multiplying polynomials. How do you multiply polynomials using our exponent rules or properties? So when you're multiplying polynomials, right, we're not multiplying monomials right now, but polynomials, we have to use a little bit more complicated system of distributing. There's a few ways to think of this. I'm going to show you 3 ways. The first is the box method. You make a box and then you have as many spots on the outside as you do of your terms. And then, just like a times table chart when you were a kid, you would multiply the things that fit into the box. So x times x is x squared. And x times 5 is 5x. X times 2 is 2x. And 2 times 5 is 10. And now we just combine our like terms. We have 2x. And then 2x and 5x is 10x, x squared, and then 2x and 5x will be 7x, and then 10x. The FOIL method is the method of distributive property. I have to distribute each term across. So first I distribute the x across to the other side. So I'd get x times x and x times 5. And then I have to distribute the 2. 2 times x and 2 times 5. It gives us the same terms that we have to combine and the same answer. Now the last method I'm going to show you is called stack. And you've always multiplied using stack your whole life. You take one term and you stack it on top of another, and then you multiply up and over. So if I stack it like I would if I was multiplying, say, 150 times 25, I would do the same thing. So I'd go 2 times 5 is 10. 5 times x is 5x. X times 2 is 2x. And x times x is x squared. And then I just add them up like I would a normal multiplication. The nice thing about this one is that it puts them in the right grouping to be combined. So box, FOIL, and stack. That is what we're going to be doing today. Let's practice a few more. Go ahead and write this one down and do it together. For box method, we put our terms on the outside. And then we go ahead and multiply our boxes. A times A times -3, A times 8, and 8 times -3. Now we have to combine our like terms again, making sure we watch our negatives. So we have A squared, 8A, and -3A, and -24. If I do the same thing, but I do it in FOIL, I distribute the A, and then I distribute the 8. And I can find my like terms. If I do it in stack, I multiply up and over, and then multiply up and over, and combine my like terms. Oops. A disappeared. Just a sec. Okay, you try. And I'd like you to try all 3 methods, please. Pause the video here. Okay, hopefully when you did this, you saw something kind of special happen, because we call this a difference of 2 squares. And because it's a difference of 2 squares, we know that when we go to distribute here, let me just switch my color pen quick. When I distribute the a, I get a squared. And I get negative 4a. Now I distribute the 4, I get positive a, and then negative 16. So we know that a square is a square root of something, right? Can have a positive and negative. We'll talk about that in class a little bit more, because I know that I can have positive 4 times positive 4, and it will be 16. Or I could have negative 4 times negative 4, and I can still have 16. So actually, when we think about square rooting something, the answer to this should be positive or negative 4, right? Interesting idea. So this one, when I have a plus 4 and a minus 4, we call it a difference of 2 squares. So let me just rewind that for you real quick. That is a perfect square, and this is a perfect square, and subtraction means it is different. So the opposite sides cancel out the middle term. That is very different from this. This is identical twins. The other I call opposite twins. When they're identical twins and you multiply them, and if I just use the box method here, you could see I always have a middle term. So we call this a perfect trinomial. A perfect trinomial. So don't ever do this. I got 2 of them and I'm going to distribute, because that's not right. That's not right. Okay. It's not a monomial that we're distributing to. It is a binomial. So there's 2 people in the family. So you have to completely multiply the whole thing by the whole thing. Right? So we always need to box FOIL or stack any polynomials. And go ahead and try this. Now I know it says to try either method, but I would like you to get confident with all of them. Go and pause your video here. Okay, let's see how we're doing. Hopefully this is what you got. On that second one, you can see that it's a difference of 2 squares, because we have the same term and then we have opposite operations, and then we have the same term again, which is a square. Okay, what happens if I'm multiplying a binomial to a trinomial or larger? Well, this is where I feel that box or stack come in really handy, because there's always a place for every digit. I think FOIL becomes messy and people make a lot of errors when things are very large. So I strongly suggest you become very comfortable with box and stack. I like stack, but it's a very much a personal preference. So x times x squared is x to the third, and x times 5x is negative 5x squared, and x times 4 is 4x. X squared times 2 is 2x squared. Negative 5x times 2 is negative 10x. And 2 times 4 is 8. And again, this is organized so that we can combine our like terms quite easily. So we have 3 x to the third, negative 3x squared, negative 6x, and 8. Now, this binomial is to the third power. That means we have to multiply it 3 times, right? That's like if we say we want to do, I don't know, 250 to the third power. We have to go 250 times 250 times 250. And that's what you have to do here, right? This is not distributive property for the exponents because it's a family, right? It's a binomial. It is not a monomial. Monomials we distribute. This is not a monomial. So it's 3 times it. So we have to do 2 at a time, right? When I look at this one, I can see that it is a perfect trinomial because it's identical twins. So whether I box, FOIL, or stack it, and if I just go over here and slow it down a little bit and show you that if I have x minus 3, x minus 3, that I get a perfect trinomial. A perfect trinomial always has a positive last term. Okay. And now we take that number, and again, this is why box is really helpful. I need to multiply it one more time. So I'll get x times x squared, getting x to the third, x times negative 6x, which is negative 6x squared, and x times 9. Then I have x squared times negative 3, and negative 3 times negative 6x is a positive 18x. Negative 3 and 9 is negative 27. Hopefully what you're seeing here is it's really important that we need to understand all of our rules here of multiplying our exponents, but also multiplying integers, right? When we have a negative times a negative, it's a positive. And if I have a positive times a positive, it's a positive. And if I have a positive times a negative, it's a negative. Remember, we talked about relationships to remember that one. And then when I'm adding or subtracting, then I'm really kind of going back to that who wins game, right? How many is actually left over. All right. Go ahead and try this one. Pause the video here and let's see how you do. Again, with any trinomial times a binomial or larger, right? If I had a trinomial times a trinomial, I'm always going to choose to use box because it just keeps things lined up. I also enjoy stack, but I'm going to show you guys box because I just feel my students do the best with this one over time. 2x times negative 3x to the third is going to be negative 6x to the fourth. 2x times 2x is 4x squared. 2x times negative 5 is negative 5x. Our second row, 3x to the third times 4, negative 4 is positive 12x to the third. Negative 4 times 2x is negative 8x, and negative 4 times negative 5 is a positive 20. And then we combine our like terms. Notice these are not alike. These are, and then this one. So what you'll often see, if I have a binomial times a trinomial, you should end up with 5 terms after that, unless you end up with some sort of some differences of some squares in there. Okay, give it a whirl, pause the video. And hopefully this is what you got. Now, if you're working from home and you want to work through some of these on Zoom, just send me a message and let's set up a time to meet. 1A or 1B is a really good time for me, but I can also Zoom in the evenings if that works for you. I know these are big concepts and I want to make sure that you understand what you're doing, okay? So come Zoom with me if you want to have some individual practice.